In the previous video, we learned that a homologous series is a group of organic compounds having similar general formula and similar chemical properties in which the successive compounds differ by a CH2 group. We even had a question based on this, that the consecutive members in a homologous series differ by which group? The answer is CH2 group. As we all know, that there is hardly any walk of our life where we do not come across the organic compounds. And well, there are more than 5 million organic compounds are known today, and thousands of new compounds are added every year to the existing lot. So it is quite important for us to understand how to write the structure of organic compounds. Let us consider an example here. As you know, that carbon has a unique property of self-linking. So it can form a long chain of carbon atoms and it form a compound. Thereby you know that the carbon being tetravalent in nature, so in order to satisfy its octet configuration, it is covalently linked with other atoms. So hereby you can see how the carbon atom is being single covalently linked with the hydrogen atom and the carbon atom. Thereby each carbon atoms are satisfying their octet configuration, and this is how a structural formula of an organic compound has been written. But the problem will arise when there is a long chain of carbon atoms. During that, it is quite tiresome to write out all the covalent bonds that are present between the carbon atoms and the hydrogen atoms. So in order to avoid the tiresome work, we can also go for this condensed formula that can be represented by, you can see here the one carbon atom, how it is covalently linked with the 3 hydrogen atom, that can simply be written as H3, and you can represent a single covalent bond that exists between the carbon first and the second carbon atom. And coming to the second carbon atom, which is covalently linked with the 2 other carbon atoms and 2 hydrogen atoms, where you can be written as CH2 and a single bond which is there between the second and the third carbon atom. And the third carbon atom as CH2 group, and again a single bond present between the third and the fourth carbon atom. So the fourth one is CH3. So as you can see, you can ignore the single bonds that are present between the carbon and hydrogen atoms, and you can simply write the number of hydrogen atoms that are being bonded to each carbon atom. But it is mandatory to put this covalent bond between the carbon atoms. So here a question will be arising in your mind, that why do we specify the covalent bond between the carbon atoms but ignore the covalent bonds present between the carbon and hydrogen atoms? See, this is what the structure will look like when you ignore the covalent bond between the carbon and carbon atoms. The problem will be when you ignore the covalent bonds between the carbon and carbon atoms, you cannot know that what type of bond that is present between the carbon and carbon atoms, because you know that between the carbon and hydrogen atom there is the presence of always single covalent bond. But when you come to this unsaturated compounds like alkene and alkynes, there the representation of double and triple bonds must be there. So in this case, if you ignore these bonds that will be present between the carbon and carbon atoms and you write the structure like this by ignoring the covalent bond, so here you cannot understand like what type of bond that is present between the first and the second carbon atom. And hence the representation of this formula, the condensed structure of this above formula will become here wrong. So for that reason, it has to be specified the covalent bonds that must be present between the carbon and carbon atoms. So you can specify if it is double bond, you can specify the double bond between the carbon atoms, and if it is single bond present between the carbon atom, you can specify the single bonds as well. And the hydrogen atoms, simply you can put out the hydrogen, the number of hydrogen atoms that are attached to this carbon atom. As the first one, you can see how it goes as the CH2 double bond CH and the single bond present between the second and third. So it is CH2. Then comes the fourth carbon atom, that is CH3. Comparatively, the same you can find in case of alkyne as well. The first carbon atom, as it is covalently linked with one hydrogen atom, that is CH, and it forms a 3 covalent bond with the second carbon atom, that is CH triple bond C. Then here goes how the CH2, then here comes the CH3. Hence the formula is CH triple bond C, single bond CH2, single bond CH3. This is how the condensed or the short form of a structural formula is written by ignoring the single covalent bond that is present between the carbon and hydrogen atoms, but by specifically mentioning the type of bonds that are present between the carbon and the carbon atoms. So now here goes a progress check for you, that what is the condensed formula of the following structure. As you can look, this carbon atom is being linked to 3 hydrogen atoms. So it is CH3. You can write it by putting a single bond and representing again CH. Again putting a double bond, specifying this is quite important, following the CH2. So the answer goes as CH3, CH, CH2. Well, it will be happy for us if you visit us at vikaslearning.in and read out the testimonials that was written by the parents and the students. And reach out to us for any queries at training.hsr@gmail.com. You can also contact to us at the WhatsApp 86181 54620. Thank you.